Shannon, what are you doing?
I'm on the hunt. I'm looking for shapes. I'm trying to find them. I found it! I found the family tree of 3D shapes. This side's the polyhedra side. Polyhedras have faces, edges, and vertices.
This is a prism because it has two faces that are the same shape. They could also be triangles or hexagons or any other kind of shape. They also have parallelogram lateral faces, and lateral faces are just the faces that aren't the bases.
This is a pyramid because it has one base and all the lateral faces meet at one point. This is the non-polyhedra side and are classified as this because they have curves, unlike polyhedras.
The three types of non-polyhedra are cones, spheres, and cylinders.
We're at Lawleakers!
And we're looking for 3D shapes.
This is a cylinder. It's a cylinder because it has one circle here and another circle here. And they're parallel and attached to each other by a curved surface.
This is a pyramid because it has one base and all of the triangular faces meet at one vertex.
A sphere. A sphere is a 3D circle and it doesn't have faces, edges, or vertices.
The surface is made up of many imaginary points, and every point is equidistant from the center of the sphere. We're at Daddy-O's.
And we found cones.
This is a cone because it has a circular base, and it has a curved surface that attaches the circle to a single vertex.
This is a prism because it has two bases, both parallel to one another. They're connected by parallelogram faces.
The bases don't have to be square like this one. They can be any other shape except for circles. Leonard Euler was a famous mathematician who came up with a formula to find a missing face, edge, or vertex in polyhedra.
This formula is F plus V equals E plus 2.
F stands for faces, V stands for vertices, and E stands for edges. Here we have some examples of Euler's formula. I'll be solving number 1. Would number 1 be a hexagonal pyramid or a hexagonal prism? That's right, a hexagonal pyramid, because it has one base, that's the hexagon, and all of the triangular faces meet at one common point. Now we're going to solve the problem using Euler's formula of F plus V equals E plus 2. This shape has 1, 2, 3, 4, 5, 6, 7 faces, and we don't know how many vertices, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges, plus 2. 7 plus 3 equals 12 plus 2 is 14. 14 minus 7 is 7. So it says we have 7 vertices, so let's count. 1, 2, 3, 4, 5, 6, 7.
I will be doing number 2. Now, is this shape a triangular prism or a triangular pyramid? That's right, it's a triangular prism. It's a prism because it has two triangular bases and parallelogram faces connecting the two. We're going to solve for edges using Euler's formula. Formula goes F plus V equals E plus 2. Now we know the faces. We have 1, 2, 3, 4, 5. Plus 1, 2, 3, 4, 5, 6 vertices. We don't know what the edges are, and plus 2. Now 5 plus 6 is 11, E plus 2, minus 2, minus 2, 9 equals E. So there are 9 edges. We can be sure of this by counting. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9.
When it comes to Platonic solids, there are three main questions. What are they? How many are there? And what are each of them called?
What are they? They are regular polyhedrons that have regular congruent polygons as their faces and congruent edges. How many are there? 5. These are the 5 types of Platonic solids.